Welcome everyone to the AGEMERA Critical Raw Materials and Smartphone Lifecycle Online Game Introduction Seminar. We're delighted to introduce you this brand new educational game and to explore the fascinating journey of a smartphone from raw materials to recycling and through an engaging online game on the same topics. So together we will be diving together to this wonderful world of the smartphones. A little bit about the agenda that we are planning to do today. I will begin with the short introduction to the AGEMERA project to provide some context and on how this initiative supports education on critical raw materials. Then my esteemed colleague Tony Hand, who is also here, will guide us through the key knowledge areas essential for navigating the game. So these include importance and strategic value of critical raw materials, rare earth elements and their global demand, the role of recycling and the circular economy, as well as global supply chains and logistics, and the ethical and environmental dimensions. After that, we will jump into the game itself with a live walkthrough with me, Henry Suomalainen, a specialist at the Taltech Department of Geology from the Division of Mineral Resources and Applied Geology. And then we will wrap up with the Q&A session. If there are any questions throughout the seminar, you can use the chat section or the Q&A section or the tab in Microsoft Teams as well, if you have any questions on the go. And this game is designed to be both informative and fun, blending science, sustainability, and storytelling as well. And it's a great way to explore the life cycle of a smartphone while reflecting on the broader impacts of the technologies that we use every day. So let's get started and uncover what's really inside the mobile phones that are inside our pocket. To begin with, let me introduce a little bit the AGEMERA project, the initiative that is behind this game that we're introducing today. The AGEMERA project, or Agile Exploration and Geomodeling for European Critical Raw Materials, is a Horizon project, European Critical Raw Materials Modeling Project, and we're funded initiative that is aimed to boost Europe's ability to source critical raw materials responsibly and sustainably as well. The project was launched in August 2022 and it's running to July 2025 year, and AGEMERA brings together different partners from around 20 partners from 11 countries that are highlighted on the map on the right-hand side, and the main coordinator of the project is University of Oulu in Finland. AGEMERA supports the EU's Green Deal by advancing innovative, socially responsible and environmentally sound methods for exploring and modeling Europe's raw material potential. The key outcomes of the AGEMERA project are the improved models for mineral exploration, environmentally friendly, non-invasive geophysical methods, AI tools for integrated data analysis, frameworks for community engagement and social acceptance, and educational materials to promote sustainability awareness. And the EU has also launched several initiatives, including the European Raw Materials Alliance, which is focused on resilience and secure supply chains, as well as promoting the circular economy, and the European Raw Materials Act as well. And these efforts support the EU's goal in collaboration with the United Nations framework for a sustainable future as well. Now I'll hand over to my colleague Tony, who will give a brief presentation on the key topics of the game that are essential knowledge to go through the game. So Tony, now I'm giving you the control.
Lovely. Thank you very much, Henry. So yeah, we're going to go through, where does the materials come from to make the phone that sits in your pocket or is on your desk at the moment. It's quite a complicated journey, but we can go through it pretty quickly just to see the main points and to see how these things are put together, and we can then play the game to see how it all works. So yeah, this is key knowledge. It's basically looking at the main points of how things are put together. So the makeup of a mobile phone uses what's known as critical raw materials. And why are they critical? Well, the EU has every few years comes up with a list of what they regard as important, critical, and strategic raw materials. The current list is 2023, but the whole idea behind it is that we have to try and source more of these materials because they are used in the high-tech products for renewable energy, and particularly, the solar panels, windmills, battery materials as well. So they are very important in electronics, for all sorts of electronic technology to function correctly. And of course, we have to look at how it is to develop the EU's economic growth and also the national security side of things, because this is one of the major geopolitical issues happening at the moment. But countries that have accesses to these critical raw materials can have a big advantage and almost a monopoly, which we will see now in a moment. But the demands are increasing globally for the critical raw materials. So Europe isn't the only one looking for these critical raw materials and trying to use them. Everyone else is looking for them as well. So we have to be a bit more looking how we become more strategic and more planning. Yeah. So the current critical raw materials list is this. It's made up of 34 different elements. You probably recognize most of them, but the ones we look at more, a bit more in detail would be the rare earths. You can see they're heavy rare and light rare earths. We'll look at them in a moment. And the lithium and the cobalt. We look at those. We'll pick those out for special attention. Just wondering, could we mute our microphones, please?
Yes, I did it.
Thank you. Yeah, so let's look at lithium. The images here are lithium in two forms. One is a solid. It comes from material called spodumene, and the other is from it's salt, which is brought to surface, pumped to surface, and the evaporation causes the material to be dried out and left behind. They're very important because, as you can see, batteries for electric vehicles. But even if we look at our technologies, the remote control of your TV or something like that, it's often lithium batteries that would be in it. But from a strategic point of view, this is becoming not quite geopolitical, but we can see that there's a lot of the countries that are supplying lithium are in the southern hemisphere. So how do we engage with these countries? How do we ensure that we can have stable supplies for our own energy purposes and our own transportation systems? So this involves proper relationships with these different countries. Now, along with the critical raw materials, we have what's called rare earth elements. Now, rare earth elements, as you can see from the periodic table of elements, they all belong on that one line there, the lanthanide group, and they have kind of first cousins in scandium and yttrium up there as well. But you can see the different colors represent light rare earths and heavy rare earths. And we don't have to go into too much detail there. The difference between them is that the light rare earths have it's the atomic weight factor is what puts them into two different categories. So yeah, global demands. As I said before, Europe isn't the only one looking for these. So there's quite a big competition because you can see they're used essentially for the likes of our smartphone and other technologies as well. Like, you can see magnets, catalysts, and things like that. So demands, as I said, is increasing, and the competition is increasing as well. So from a European perspective, we have to look at a stable supply of these because economic growth will be very much affected by the availability of these and national security as well. And of course, as I said before, the countries that have these have a huge advantage globally. And if we look at this, China supplies almost all of the rare earths globally. If you see that list on the right hand side, you'll see the light rare earths and the heavy rare earths, 99, 98% respectively, is from China. So they have the market there. If we look at also Chile supplies 78% of the world's lithium. Uh, so we have to be uh, how to say we have to build up proper relationships and proper supply chains and things like that. But rare earths, no, they're not rare. Because the reason they're regarded as rare earths is they have how to say they don't come in one particular form. They come attached to other types of minerals. So the major I would say challenge is that to separate them, it takes an awful lot of energy, an awful lot of water, but we have to have them because technology, if we don't um, access them, be able to form concentrates and process them, then we won't advance too much if we don't have access to them. But are they rare? Yeah, you can see this that the least rare of them, cerium, 15,000 times more abundant than gold. And even the rarest one is 120 times more common than gold. So you can see they're not rare, but it's the challenges of separating them from other materials and themselves, and they come in low concentrations as well. So we need a lot of them. A lot of work goes into getting a small amount of material. So look at the supply chains and how they're transported. How do these things get from out of the ground to our pockets? So it all starts at the beginning, exploration. We have to find out where this material is. And this is where the technological advances of the AGEMERA project are going to help us. They're going to help us pinpoint more accurately where this material is and how we can go in and hopefully extract it in a less energy intensive way, a less damage to the environment, and have a more responsible and sustainable supply chain. So you can see it goes through the processes, transportation, the material goes to smelting, then the manufacturers buy the material and use it to make products. Then we also have the substitution where we're looking at how can we replace some of these materials with other materials. And of course, then the final product. And then after the end of life of the product, it goes into the recycling stream. And then what we call the circular economy, which we'll have a quick look at. So here's just a quick process. We'll look at aluminium, for example. Whoops, that's a bit too quick. Yeah, so we can see the extraction process. It's brought then, the bauxite is the main raw material for creating aluminium. It's brought then through crushing processes and some early separation process. And then the bauxite itself is brought to further refining, and it becomes alumina. And then that is brought uh, further again to smelting processes where it's developed into different products for different manufacturers to use. And we can see then at the end of the whole stream there is the final product. It's used particularly for vehicles and transportation because of its light characteristics. So there's issues with the supply chains, and of course the major one at the moment we know is geopolitical tensions, because if companies are trying to source materials in different markets, then there can be the different countries can have different restrictions on the materials. And the environmental and social concerns are always there because it is a very energy intensive. It can do a lot of environmental damage and also to communities within the regions. So the supply chains, yeah, there's a number of suppliers and countries, and if there's a weak link in any of that chain, then a lot of problems can happen. Regulatory and trade barriers, where we can see at the moment the kind of trade problems that are happening in the world. It's creating a lot of confusion in the markets and things like that. And if we look at market volatility, which beforehand there was fluctuations, it depends on the demand and the amount of material available, and that can drive prices as well. And that can drive prices up, or it can drop them really low if there's too much of the particular material on the market. Technological challenges, of course, we've seen how technology, how do we advance technology if we haven't got these particular materials? So it's a bit of a catch-22, but we have to see how we can use the better technologies to create a more sustainable extractive sector, and also a responsible one as well. And of course, when we have the pandemic impact, that really disrupted not only the operations, but the whole supply chains as well. So we have to be aware that some of these things can come out of the blue just like that. So we have to be much more stable and secure. So looking at recycling and the sustainability side, well, as I mentioned earlier, the circular economy is the model we want to go by now. The top right hand corner is the linear economy, which we've used and in most cases are still using. It's where we extract, we make, we take the materials, make something out of it, and then we just put it to landfill or somewhere like that. But this closed loop system where we want to keep the materials in circulation for as long as possible is the circular economy. Now, it does create waste, all these steps of the way, but the idea behind it is, can some of this waste be reused for other sectors? And this is where terms like industrial symbiosis comes into play. So it's like, some person's trash can be another person's treasure. Urban mining, this is a term that's become used over the last decade or so, is where we're looking at reclaiming the raw materials from products that are already in the system or in different waste streams. And again, it's part of the circular economy that we should try and reduce this and not just put it to landfill, but we can recover a lot of valuable materials, which, we can use our mobile phone, for example. So the rare earths and the e-waste, we can take materials back out into the system, and this puts less pressure on mining new materials. And of course, environmental issues are there as well. And if we can promote a more sustainable and resource efficient economy, then it works for the benefit of everyone. But of course, ethical and environmental issues are always to the fore when it comes to the extractive sector. So we are aware, this always makes the headlines, ethical issues of child labor and the terrible working conditions. And particularly we can see in the Democratic Republic of Congo, where it's something like over 60% of the world's cobalt supply comes from. And of course, human rights abuses, exploitation of workers, all these things are what comes to the fore when we think of the extractive sector, especially in Southern Hemisphere countries. But it's not all bad news. There are, in a lot of cases, better labour conditions. As with the picture in the previous one, all those people working in the mine had safety equipment, helmets and things like that, which is not often the case. So, and the community benefits as well. There's a lot of infrastructure can be put in, like schools and roads and maybe rail lines, healthcare centres, better support for the communities. And the whole idea is to reduce pollution and create sustainable mining. So it can happen, but of course the environmental issues as well are the ones that always come to the fore. The degradation that happens, the contamination of water supplies, not just locally, but this contamination can hit communities way downstream as well. And of course the loss of biodiversity is always an issue. But again, there are positive developments here. The rehabilitation of mine sites is a big thing. There are some great work happening in this area as well. And of course, water recycling that can go through different water treatment plants and reuse the water in the processing side of things and in the systems as well. And of course, emission controls, these are becoming a big issue as well. And look at the waste reduction, because if we look at the image of the circular economy, we can see waste comes out at every step of the way. So we have to either produce less waste, or what do we do with that waste? And if it's of use to somebody else, then that's the way to work together to try and create a way of proper waste management. And of course, energy efficiency. As I said, the critical raw materials and the rare earths, it takes a lot of energy to separate these. So we have to be a bit more how to say, cognizant of the energy uses and this kind of thing. But with the new technologies, this hopefully will improve. So yeah, with that, I will hand back to my esteemed colleague, Henry, and we can go through the life cycle of the smartphone. Over to you, Henry.
Yeah, thank you, Tony. For the next part, now you have some background knowledge on these topics as well. We will also upload the presentation that we did today to the AGEMERA website, so you can find it all in the same place. But now we will go to the next part, which will be a gameplay walkthrough. I will send you the link to the game to the chat as well. And now I will share you my screen, and we can start going to the game all together and to see how the game looks like. It's a brand new game, so I will start from the AGEMERA website that you can see how to reach the game as well. So going to the game, going to the AGEMERA website, we have up here on the panel CRM game, which is a critical raw materials game. And here down below, we will be providing different language versions of the game. At the moment, there's the only English version, but other languages, for example, Finnish, Estonian, Portuguese, and so on will be provided for the game as well. To start the game, click Start the Game, and from the right-hand side, choose Smartphone Life Cycle Exploring Critical Raw Materials. And then here's the game, and you can open it in the full screen mode. This is the opening part of the game, and just click Start to start the game. The navigation part is quite easy. We have Clifford here, who is going to help us out with some additional information and other information buttons as well. And you can just go back or next from the buttons down below. Registrations means that you can just type your name here. I will enter my name and read. And then just click next. And you can open up the game by yourself as well and try it out together with us. As it's so, the game is a little bit with the storytelling format. And in the beginning, it also creates the story, and the story spreads throughout the game with some texts that are in between different questions. So we will follow the smartphone through its entire life cycle, from the design and development, raw material extraction and processing, and assembly to post-consumer recycling. And there will be 20 questions in total about critical raw materials and their applications, as well as different topics related to the mobile phones. The structure of the game will be following. There will be 5 different stages, as we can say. We will start with the design and development, starting from the conceptualization, market research, software, hardware development, prototyping. The second part will be the industrial production, starting from the raw materials, extracting them, processing, and manufacturing different components. The third part will be assembling and packaging, and in between the transport and logistics. Transport and logistics, again, to the usage from the customer use, services, and support. And to end the cycle, there's 2 possible ways. When we have end of usage, we can go the green way to recycle it, resource different components, and recover different materials from the smartphones, or just store them at home. And if they go to the landfill as well, but in some cases they can also go back to the system again. And then we can start again from the processing and manufacturing different components and use the circular economy principles as well. So the first stage will be design and development. And down here, we can see that we already have some additional information. This is just for the storyline, just a little bit for the evolution of the mobile phone, because the new generation, they even might not know how the mobile phones or the smartphones looked before the ones that we have today. And we think it's a good addition for the players from this century. So the first question, and I think Tony is going to help me out on that. What is the first step in designing and developing a new smartphone? So what do you think? I think I provided some information as well.
Yes, yes. Let me think for a moment. Yeah, all these answers seem to be very relevant. But if we think of the how the smartphones, have developed, have evolved over the number of years, I would consider maybe conceptualization and market research. That has to be a kind of a big one. What do people need, or is there a spot in the market that can be filled? I would say C in that one.
Okay, let's click submit and see that this was the correct answer. And after each of the questions, we will have an explanation to the answer as well. And here it says that the development of a smartphone is driven by consumer needs and market trends. At this stage, the key features, functionalities, and design solutions of the device are defined to meet user expectations, and so on. And then when you click continue, you can reach the next question. So the second question will be about phone components. Which of the following parts is not an essential component of a smartphone? Is it screen and display, charging port, battery, or a circuit board?
Oh, this is a contentious one here, Henry. But you do need a screen and display, of course, and the battery. It won't work without a battery, and the circuit board, which is made up of all these critical raw materials and rare earths, makes the phone work. But the charging port is the one that we can do without.
Yes, but just to show, I know that the charging port is the correct answer, but just to show what happens when you choose the incorrect answer. For example, here, let's choose the battery. We need the battery for the phone to run. And when you click submit, it's going to say not quite, try again. And then for the second time, when you click the incorrect answer, it's going to show you the correct answer. So in this question, the charging port truly isn't the thing that we need for the phone, for what is not essential or critical for it. Because screen and display, they contain indium, a critical material for touchscreens. Battery use lithium, cobalt, nickel, essential for energy storages. Circuit board contains gold, copper, tantalum, vital for electrical connections. And the charging port, while important, is not considered a critical component or an essential component, as it does not directly impact the smartphone's core functionality or rely on scarce materials. Next question. Which of the following elements is essential for phone batteries? Is it osmium, cobalt, helium, or sulfur?
Well, we know cobalt is very important from battery perspective, especially in electric vehicles, but is it important for a smartphone? I would say yes. Cobalt.
Yes, as you can see from the additional information box, we have a couple of figures here, and we can see that for the battery, cobalt is necessary, and on the right-hand side, cobalt, lithium, nickel for the battery are necessary. And from these choices, cobalt seems to be the right answer. So we can submit the answer. Yes, and that is right. And most smartphone batteries contain lithium cobalt oxide in cathodes, making cobalt one of the most critical raw materials in mobile technology. And here are the features that cobalt helps to do. Battery and performance and stability, prevents overheating and fires, and efficient charging. Let's go to the fourth question. Which mineral is the primary source of rare earth elements that Tony spoke about before? What are key materials in smartphone components like speakers, vibrators, and display screens? And now I will tell that the information button on the right hand side is here just for the storyline to introduce that now we have reached the stage of source rocks and minerals and how the cycle starts with. But back to the question.
Well, if anyone is familiar with these materials, we know that quartz, hematite, and galena are not rare earth elements. They are basically used for other types of products. But I would suggest that bastnasite is the critical or the rare earth element that's vital for these components.
Yes, and I will just show the additional information box, which provides the same information that we had in the presentation before. Let's go back and choose bastnasite. And bastnasite is the correct answer. That's correct. So we can continue to the next question. And now we have reached the second cycle or the second stage of the life cycle, which is industrial production. And the key stages are raw material extraction, processing, and transport. And if you click down here, you can see it on the figure as well. But let's go to the next question. Which of these countries is not the significant exporter of rare earth elements? Is it Australia, China, USA, or Brazil? And here we also have on the right-hand side a figure that helps us out.
Yes, as we saw earlier, that when it comes to the rare earth elements, that China has the almost all of them, but when it comes to who provides the least amount, would I say Brazil in that one, if I can see the charts correctly?
Yes, we can see that in China we have light rare earths, heavy rare earths. In Australia, we also have heavy rare earths, light rare earths, and in USA on the map as well, we can see that they're present. So, and in Brazil, we cannot spot them on the figure. So let's see if Brazil is correct answer. Yes, it's the correct answer, and here is also the same explanation I just gave you. To the sixth question. We have the graph on the right showing the fluctuations in the price of lithium over the past years. Which of the following events led to a sharp increase in its price? Is it increased demand for electric vehicles, a major discovery of new lithium reserves, a global recession, or improved extraction of technology? What do you think, Tony?
Well, I presume we would go for number A because or letter A because the increased demand for electric vehicles, and we've seen that over the last number of years, and you can see that how the last couple of years the spike in the lithium, the demand is there because of electric vehicles.
Yes. See if it's correct, and the answer is correct. And what we can say that today there are over 40 million electric cars globally, up from just 26 million in 2022. So, of course, there has been a really large increase in that sense as well. And the trend expected to continue rapidly growing. Up to the next answer. What is a critical raw material or CRM? Is it any metal or mineral found in large quantities in Europe, a material used only in the production of smartphones, a raw material that can be easily replaced by alternatives, or a material that is essential for Europe's economy but has a high supply risk? And here in additional information button, we also have a map about the critical raw material deposits of Europe. But back to the question.
Well, yeah, we saw the potential there for the critical raw materials that are we know that are in Europe, but the fact that we don't mine them ourselves would suggest that A is not a correct answer. And we know that it's not a critical raw material isn't just something that's only for smartphones. It's used for all these new technologies, looking at greener energy and things like that. And it's not easily replaced by alternatives. So I would suggest that D is the right one because, as we've seen, the economical progress of Europe is can be affected greatly by the supplies of these materials.
Mhm. Let's submit. And here we can see that it's correct answer, that they have a significant economic importance to Europe and rely on them on non-EU countries. Yeah, and CRM play a key role in a wide range of everyday items and appliances beyond just smartphones. So to the next question, which is related to the extraction, processing, smelting, and refining. Which of the following raw materials requires the most energy-intensive process for extraction and refining before it can be used in smartphone components? On the right-hand side, we also have the storyline element here, and down below we have the same aluminium figure that we saw in the presentation before, and just some additional information on those answers here. So, Tony, what do you think? What is the correct answer for this question?
Well, we've, as we've done in the introduction to this, that the rare earth elements are, use an awful lot of energy because they come attached to other metals and minerals. The process of separation is very energy intensive, and while all of these metals, when it comes to the smelting side of things, are they use quite a lot of energy. The rare earth elements are the ones that use the most energy.
Yeah, I can agree with you. Let's submit. And that's right. Rare earths require the most energy-intensive extraction and refining processes due to their complex geology and chemical properties. And the refining process involves multiple steps, including solvent extraction and ion exchange, which consume significant energy and generate substantial waste. To the next question, question 9, about transport and logistics. Which of the following transportation methods would be the most cost-effective for transporting smartphones over a long distance? So, for example, from Asia to Europe, but also considering the environmental impact. On the right-hand side, we also have the storyline, a little information about the transport and logistics. But here the answers for the question are either air freight, ocean freight, rail transport, or truck transport. What do you think, Tony?
Well, we're always told that, to be more conscious of our carbon footprint, that rail transport is the one we should take, but that's not practical when it comes to transportation of these critical raw materials and rare earths. Because, as we've seen, they come from generally the southern hemisphere, and the rare earths are concentrated in China. I would suggest that air freight, too costly, truck transportation won't work. So therefore, ocean freight would be the pick there. Yeah.
Mm-hmm. And it seems to be the correct answer, that shipping is the most cost-effective and practical option for long distances like 1600 kilometers, and it also balances emissions and cost for bulk transportation. While it takes the longest in time, the cost savings and moderate emissions make it the most sustainable choice for this scenario. Up to the next question, which is related to manufacturing of different components. So in the process of manufacturing smartphones, which of the following parts cannot be salvaged from discarded electronics for reuse in new devices? On the right-hand side, also the storyline, and the answers are lithium-ion batteries, motherboards, plastic casings, or cracked smartphone screens. What do you think?
Well, lithium-ion ion batteries, of course, we know they can be recycled and made into new products again. The motherboards, they contain the critical raw materials, rare earth elements, so they can be salvaged and recycled. The plastic casings, while they're not essential, it's possible to do it. But I would say D, the cracked smartphone screen, because the smartphone screen is made up of quite a number of different rare earth elements to make it function as a touch screen and things like that. So that would be the hardest one to salvage.
Yes, this is correct. And also they contain different elements, as Tony said, rare elements. Cracked screens are generally not suitable for direct use, reuse in new manufacturing, as they no longer meet the quality standards required for new products. And while materials from broken screens can be recycled, they usually need to be processed and purified before they can be reused. To the next question, which is again related to transport and logistics. Which of the following regions would likely have the lowest carbon emissions when transporting critical raw materials like lithium and cobalt for smartphone manufacturing, assuming optimized transportation routes? Is it rather North America, South America, Asia, or Europe? And I think here below the additional information, we have the map here to help us out on the question.
Interesting one. And if I get this one right, Henry, do I pass the test? Because that'll be 11 out of 20. So I get 50 something percent. So yeah. It's a hard one to pass the test on. The lowest carbon emissions when transporting critical raw materials like lithium and cobalt for smartphones. So we can rule Europe out of that because we don't produce it. Well, we have the potential to do it, but we don't do it yet. And Asia, of course, is a pretty long distance away, and North America, I would go for probably South America.
Yeah, because we can see that cobalt can be found in Africa, and South America contains lithium deposits in Chile or Argentina that are marked on the map. So let's go with South America, and this is the correct answer for the question. And here is also a short explanation for the question. So now we're halfway through. And let's continue with the game. Clifford is on our side. So the next cycle phase is stage 3, which is assembly and packaging. And now we've gone through the design and development part, the industrial production part, the transport and logistics. And now the questions will be related to assembly and packaging. Let's see the next question. Which of the following is the most important consideration when choosing a transportation method for smartphones to ensure they are protected during shipment and storage? Is it speed of delivery, cost of transportation, protection from physical damage, or environmental impact on transportation? What do you think?
Let me see now. Choosing a transportation method for smartphones. Well, yeah, we've already seen that using cargo ships to transport is the most, how to say, sustainable or less environmentally damaging way to transport it. And of course, that means the speed of delivery isn't a top priority. The cost of transportation, of course, is always something to be considered, but we know that the environmental impact on the transportation, but I would go for the protection from physical damage, because if you're transporting it across oceans, storms, things like that, you need to ensure that the product arrives in a proper way.
Yes, otherwise we won't have the product that the customers want to have. So this is the correct answer. And while speed, cost, and environmental impact are also important factors to consider, the protection from physical damage is the most important factor when transporting smartphones, as these devices are delicate and can easily be damaged during transit. Okay, let's go on to the next question, which brings us to the next cycle, which is the usage cycle, customer use. So the smartphone usage phase begins once the device reaches the consumer. During this phase, the phone is actively used for various purposes, including communication, entertainment, and productivity. Lifespan of a smartphone is typically 2 to 3 years, and efficient energy use is also something that we need to think about. So the question related to the phone usage, as you can see, some of the questions now might become a bit more difficult, the level of the questions rises throughout the game as much as possible. So, but what is one effective way to lower the environmental impact of how much energy your smartphone uses? Is it adjusting settings like brightness and background apps to reduce energy use? Is it keeping the phone plugged most of the times to maintain full charge, using a high voltage charger for fast charging, or frequently replacing the battery to maintain efficiency? And here we don't have any additional information provided as well. What do you think, Tony?
Well, many of us have tried to replace the battery in one of our phones. Like it's either virtually impossible, or it can be an expensive thing to do. Using a high voltage charger for fast charging, well, again, that's something that depends on the person using the phone if they can do that. But keeping the phone plugged in doesn't make sense at all because it's constantly charging. It affects the battery life. So we all know that adjusting settings, your brightness, your background apps and things like that to reduce those to create less energy use. So I would go for A.
Let's see if it's correct, then it's the correct answer. Yeah, this is the most easiest way to do it. Up to the next life cycle, which is the post usage or end of life. And now it's the fifth stage of the cycle, and we are now coming close to the end of the life cycle. But let's see questions that are related to this cycle stage. So, which of the following is a chemical process used to recover gold and CRMs like cobalt, lithium, and tantalum from old smartphones? Is it hydrometallurgy? Is it smelting? Is it urban mining or incineration? And here in additional information, we also have the explanations to the methods. But what do you think, Tony?
Oh, well, incineration is something that you can see it involves burning the waste at high temperatures. So if we burn the critical raw materials or the elements in a smartphone, then they're gone for good. We won't have them again. Urban mining, of course, is what we've seen in the slide is the start. It's how do we get all this material together? Smelting, of course, is where we really look at the actual raw material itself being processed, but hydrometallurgy is where it's really studying deeply into how these materials can be extracted and reused in the system again.
So hydrometallurgy. This is the correct answer. And hydrometallurgy is the most effective method for recovering gold and CRMs from old smartphones using chemical solutions to extract metals efficiently. And unlike smelting and incineration, which involve high temperatures and emissions, hydrometallurgy is more targeted and environmentally friendly. And urban mining is a broader concept that often relies on hydrometallurgical processes to recover valuable materials from e-waste or electronic waste. Up to the next question, which is related to the post-usage stage. Based on the global recycling data, which region recycles the highest percentage of smartphones? Is it either Europe, is it North America, is it Asia or Africa? And here we also have the additional information button. Let's see, what do we have here? It's just explanation how the process works, and down here just an example how the end-of-life mobile phones can be spread apart. But back to the question, what do you think, Tony?
Well, indeed, we have to look at the recycling when it comes to collection. How do we collect all this material? What infrastructures are in place to do it? And how does it go then? That image just showed how to separate parts into the different breakdown into different products that can be recycled again. So, and I know for a fact that when it comes to recycling rates of anything, Europe is the top there on a global scale.
Let's see if it's correct, and it seems to be correct. And as we can see, Europe is a global leader in electronic waste recycling, including smartphones. So we have strict environmental regulations, such as the Waste Electrical and Electronic Equipment Directive. On the right-hand side, we can also see from the Global E-Waste Monitor from 2024, and the graph is based on 2022, that Europe generates the most e-waste, and the e-waste documented to be collected and recycled per capita, and the annual average formal collection and recycling rate is also the highest for Europe, so around 42.8%. So now I click the wrong button, and let's go to the next question. Recycling raw materials is important to reduce reliance on finite resources and minimize the need for mining new materials. What percentage of smartphones worldwide are currently recycled? Is it 90%? Is it 50%? Is it 75% or around 20%? What do you think? Is it rather more or rather less?
Well, if we look at the previous question and we see that what Europe is the highest recycler, but it's still only was it 40-something%, and that goes to show that we are not recycling at a high rate at all. I would go for the lowest there, around 20%.
This is the correct answer as well, and we can see that from the same source. Small IT and telecommunication equipment, total e-waste generated was 4.6 billion kilograms, and 1 billion of kilograms was formerly collected and recycled, and 22% of the small IT and telecommunication equipment, for example, smartphones, were recycled in that sense. So it's just recycling that needs still to be developed in different regions. But what percentage of earth elements are currently being recycled in the European Union? Now we're getting even more smaller scales. Is it around 1%? Is it around 10%, 20%, or more than 40%? Because we've heard European Union has different directives and acts, but what do you think? What is the answer for this question?
Ooh. Well, yeah, as I said, the European Union is we have the WE directives and these kind of things as well. But I would still suggest it's low. I'm going to have a stab at maybe 10%.
Around 10%. Let's see. That's the correct answer. Not quite. Try again, Tony.
Oh dear. Well, then let's wait, let's think. This is complicated. And of course, we've seen that even though we're from a European perspective, we recycle at a high rate, we still have so much more room to improve on that. So could it be 1%?
Let's see if it's around 1%. That's the correct answer.
Oh,
from
that's
the graph
bad.
below, we can see that end-of-life recycling input rate of critical raw materials in the EU. The highest is copper, tungsten, aluminium. And when we take a look at the rare earths, they're around 1% here, next to tantalum and titanium metal. So there's a long way and a long road to improve in that sense.
Indeed, yes.
Yeah, and we also rely mostly on China on this part as well. So yeah. Going to the next question. Okay, now we can see that we're almost done. Clifford is even crying, and now we have advanced million-dollar questions. So the questions are going to become a bit more difficult, that you will have to read the questions to exactly understand. So, if the recycling rates of critical raw materials from mobile phones increase by 30%, how would this affect the environmental impact, economic savings, and supply chain stability for smartphone manufacturers? Is it going to be higher environmental impact, increased costs, and unstable supply chains? Is it going to be reduced environmental impact, lower costs, and more stable supply chains? No change in environmental impact, costs stay the same, and supply chains remain unstable, or significant reduction in raw material extraction, no economic savings, and unstable global market. Which is the correct one?
Well, it can only improve if we can increase by 30%. So if we could do that, it should reduce environmental impact, lower the cost of the materials, and create a more sustainable supply chains.
Let's see if it's the correct answer. It is. If recycling rates of critical raw materials from mobile phones increased by 30%, it would lead to a reduced environmental impact, as fewer new materials would need to be extracted, lowering mining-related pollution and energy consumption as well. And this would also result in lower costs for smartphone manufacturers, as well as more stable supply chains would emerge, as the reliance on recycling would reduce vulnerability to global supply disruptions and resource scarcity. So, next question is, suppose the demand for rare earths for mobile phone production increases significantly, while the availability supply from mining operations remains the same. Which of the following scenarios is most likely to occur? Is it increased price volatility, higher environmental degradation, and shift toward alternative technologies, or stable prices, lower environmental impact, and no technological advancements, price decrease, improved recycling efficiency, and more sustainable extraction practices, or the unchanged prices, stable demand, and no supply chain disruptions?
Well, of course, we've seen earlier that the markets can drive a lot of change within the industry when it comes to demand and supply. But if the demand increases, but the production doesn't, that will drive the prices up. It would also create higher environmental degradation because we need this material at all costs, and the shift towards alternative technologies could take place if we can't supply these materials. So I would go for A on that one.
Seems to be the correct answer, and I think you just explained the answer to us as well. So here is the last question. You can see that there is a lot of reading and seeing which of the options is the correct one. If global supply chains for rare earths become severely disrupted due to geopolitical tensions, what could be the potential economic, technological, social, and environmental consequences for smartphone production? So, what do you think?
It takes a lot into account there because it's looking at the economic, the technological, and the social environmental sides, which they're very, very important as well. We cannot forget those. So definitely the price will go up. Like we said in the previous one, there'll be a technological slowdown because we don't have enough materials to create new technologies. And of course, the social side of things, the job losses and the environmental degradation will only increase as well.
Mm-hmm. And it says that it's the correct answer. So, and here's also an explanation for the question. So let's see, how did it go? I should have put in your name over here because you were playing. So 680 points, and I think that 700 points were the maximum. When you click down below, you can review your results. And when you click next, it says, Clifford congratulates you.
Great.
That you have gone through the entire life cycle of a smartphone, and if you would like to play again or take on another challenge from the AGEMERA website. So I think now we're done with the gameplay. I hope you enjoyed it. And now I will switch back to the final slides that we can conclude our seminar that we're having this time. I will share the screen. And if you have any questions at the moment, then you can open your microphone or either write in the chat. So from the listeners that we have here, do you have any questions that you would like to ask at the moment? No one, Rex? So I think we can go on. And this is actually the end of the seminar. And actually, we would like to thank you all for joining us today. The presentation slides and the separate teacher's guides will be made available on the AGEMERA website for educators. The Teacher's Guide has a little bit more in-depth information about the topics and about the more educational side, the purposes, and some additional tasks that can be used in together with the CRM game. This game will also be translated into different languages, as I said before, Estonian, Finnish, German, Portuguese, and more. And these versions will also be uploaded to the AGEMERA site soon. So thank you again for participating. And if we don't have any more questions, then we're looking forward to continuing this learning journey together with you. So have a great day and thank you for participating.
Thank you, everyone. And thank you, Henry.
Yeah. And if you have any more questions, you can always contact us via email or find information on the AGEMERA website. Thank you.